Alright, so I'm going to be showing you how to record an animation in-game. So for this example, I'm going to be recording this car, which looks like that. And this is the demo drift from the Godot Easy Vehicle Physics add-on. Alright, so first thing we're going to need to do is add an animation player, which is how we're going to be viewing our recorded animation. And then after that, we're going to add a script to our main node. And now we're going to add some variables we're going to use to record our animation. So first thing is we need our animation. All right, next we need something to toggle recording on and off. And then we're going to need the time between each key. Which is a float and it's going to be in seconds. And then we're going to need the total amount of time that we've been recording. Which is also a float and also in seconds. All right, so now we're going to need to create tracks for our animation. So, and we need a variable to store the ID of each one of those. So for this vehicle, I already know what moves and rotates on this. Whatever you are animating, you need to figure out what changes in position and rotation. So I know for this, the rigid body changes in position and rotation. The wheel raycast changes in rotation, and each node underneath the raycast changes in position. So I know those are all of the tracks I need. So back over here, we can create each track. And we need one for position and rotation. All right, now we have all the variables for our tracks. Now we need to create all of those tracks. So I'm going to create a function to initialize our animation. And I'm going to clear the animation because when we stop and start recording, we want to start on a fresh slate. So now we want to call animation.add track to add a track, and we want it to be of type position. And for the rotation, we want it to be of type rotation. And then just keep doing this for all of the wheels. All right, now that we've added each track to the animation, we need to set the path of each track to the node that they'll be working on. So to do that, we'll be doing track set path and the track we're working on. And then the path. And a way to make this easier is access as unique name for the vehicle rigid body. and then you can use that in your path. So vehicle, rigid body, and then colon position. And then we need to set the rotation as well. But we'll need to use quaternion and not rotation. And then we need to do that for all of the wheels. So and it's the wheel front left, and then front left wheel position, because the node underneath the wheel, the raycast, that position gets set, and this gets rotated. So we need to get the position of this and the quaternion of this. And get the quaternion of the raycast. Now I'm going to do the rest of the wheels real quick. All right, now that all the paths are set up, we can create a function that's going to insert all of the keys during recording. So, insert keys, and we're going to take a parameter of time elapsed. We're going to float, and we're going to do animation.insert key, track insert key, and put it in our track. So vehicle position, and we're going to use record time or recording time. That will be our current time during the recording. And then we're going to set it to the vehicle rigid body dot position. And I'm going to do that for the rotation. Vehicle rigid body dot rotation. That turning. And then do the same for the wheel. Dot wheel front left. Dot front left wheel. What? That position. And then the rotation of that wheel. Quaternion. All right, now I'm going to add the rest of the wheels. All right, now that we got all of that set up, we're going to add the time lapse to the recording time. And that's just to keep the recording time current, because we're going to call this every time we want to add a key. And the current time is going to be where the last key was. All right, now we can delete these functions, because we won't be needing them, but we will need to get some key presses so that we can turn recording on and off. So if event that is action pressed, and I'm just going to use UI accept, and I'm going to set that to the opposite. So whenever it's recording, it will stop recording, and not recording, it will start recording. And if it's recording now, so it just got toggled on, then let's just print and say that we are recording, and then we can initialize the animation, and I believe that's it. And if we just stopped recording, we can print that we just stopped recording, and we're going to set the animation length to the recording time. So the animation length will be as long as you recorded. And then we're actually going to save the animation to the file system. So how we're going to do that is find path equals user, and let's just name it recorded animation.res. And then we're going to use resource saver save to actually save the animation, and then to the file path. And this returns an error. So if there's an error, if save error equals okay, which means nothing went wrong, then let's print save to file path. But if there was an error, then we can print error and then the error. Unfortunately, all this will print is just a number. So you'll have to look up that number in the Godot documentation to figure out what the error means. But that is it for our recording, our starting and stopping recording. So now we need to actually record it. We need to record it in a process function. So we're going to do that in the physics process function, since this is a physics body. And we're going to check if it's recording, because we don't want to add any keys if we're not recording. And now we're going to call cert keys, and we're going to put in the delta, because delta is the time elapsed between each process call, and we're going to be inserting keys on every process call. And that should be it. Now you can go to your input map, built-in actions. So UI accept is enter or space. I'm going to remove space because that's already used for my car. And I believe that should be it. So let's test it out. Press enter. And we got an error. And the problem is I forgot these need to be slashes. I don't know why I did that. So let me change that real quick. All right, let's try again. Press enter. It says it's recording. And I pressed enter again, and it says saved to recorded animation. So now I can go to project, open user data folder, and we have a recorded animation. So now what we can do is we can copy that into our project. And then go to our animation player and animation manage animations. And then we need to add a library and then load our recorded animation. And now we have our recorded animation. We should be able to play it right from here. And it looks like the wheels aren't rotating, so let me figure out why. Alright, so I forgot that the node underneath the ray trace is also rotated, so we need to add that in. So I'll do that real quick. All right, I fixed it. So all I did was I added the quaternion from this node in there, and I renamed the original rotation track to turn because all that rotation is used for is for the turning of the wheels from left to right. So there's all that, all the tracks, all that set up. And we can go back and we can record an animation. And enter both times to record and start recording, and it's saved to recorded animation.res. And then we can go back to user data folder, copy that, and open our resource folder, paste in, overwrite, and then go back to our animation player, and it will automatically reload from the file. Now we can play that animation. And that looks pretty good. As you can tell, there's no smoke, and that's because the way the smoke generates is using some internal variables from the vehicle rigid body from the let's see. So it uses the slip vector of each wheel to generate a smoke particle, but that's not working because we are animating the vehicle. It's not doing any calculations. So if you wanted to generate smoke, you would have to do it some other way or save the slip vector. And there's other things like the sound of the vehicle does not save. You don't hear, or you won't hear, the sound of this vehicle that's playing when you play the game. You won't hear it in the animation. But you could change that by remembering the RPM of the vehicle and then playing the engine sound in your animation. All right, that's pretty much it for an accurate recording of a car in Godot. And it works pretty good, but one problem with it is that it's a little too accurate. Because since we are recording on every physics process, that is at least 60 frames per second or 60 process calls per second, but that depends on how you set up how often you want your physics to be called. So that's a little much. If you have any longer animations and you try and select all of these keys, it's going to take a long time to select them and to move them around. So if you wanted to change that, you would have to set up a variable that would only insert keys every certain amount of process calls. So you would have, for example, you would have a variable that said number of calls equals 0, and you would do one call plus equals 1, and then you would only call insert keys if it was equal to, say, 4. And this would insert keys instead of every 60 frames per second, it would insert them every 15 frames per second, 60 divided by 4, which would make it so you'll be able to select and move around these keys without lagging out the entire Godot editor. But the higher this number is, the less accurate your animation will be. So you kind of want to figure out a balance between the two. So I think a good balance is 3, and it won't lag for too long, depending on how long your animation is. For example, if your animation is like 4 minutes long and you didn't do this, then if you tried to select all of these keys, you would just crash Godot. So you would either have to insert less keys, or you'd have to select just some at a time and move them where you need to be, which is kind of annoying, but you gotta do what you gotta do. But that's pretty much it. That is a working recording animation of a car. So yeah, thanks for watching.